All right, looks like we are live. Let me know in the chat if you can hear me. Put a plus in the chat. That'd be great. Welcome to today's live lesson, free lesson on geometry, similar shapes. Welcome, welcome. Let me know if you're new or returning. That would be great as well, just so I know who's here, who's joining. I see that those boys have joined on Instagram. Welcome. Welcome, welcome. I'm really excited to share with you what I have planned for today's stream. It's on similar shapes. So it's a new lesson compared to last time. Last time we talked about interior and exterior angles, and today we are talking about similar shapes. For those of you on Facebook, Twitch, YouTube, Instagram, welcome. Yes, happy Monday, those boys. Hope you're having a great day. Really excited. Polar Bear, welcome as well. I see you've joined. All right, well, um, yeah, I mean, today we're talking about similar shapes. If you are here for the free lesson on geometry, you're in the right place. If you'd like to access today's workbook, it is in the video description below the YouTube video. So you can go ahead, find me on YouTube if you're not on there already, and access that workbook. It should be the first link in the video description. All right, well, let's get started. Or actually, before we get started, if you could do me a favor, copy that link at the top of your browser, share it with someone who you think would benefit from today's lesson on similar shapes. You're probably going to see some stuff you may not have seen in school in your geometry class just yet. So really excited to show you stuff for that. Otherwise, be a supportive friend, supportive family member. Share that link with anyone that you think would benefit from today's lesson. All right, well, a little bit about me. I am Eddie Kang. I'm the senior math teacher at Space. I've been teaching for 9 years in high schools and colleges. I've private tutored every grade level from 6th grade math all the way to students preparing for graduate school. I've got all A's in my math classes myself in my mathematical journey. I got a perfect score on the SAT and eventually got into my dream school at UCLA. After graduating from UCLA with a pure mathematics degree, I started teaching right away and found really early on that I'm very passionate about teaching mathematics, making the challenging concepts simple to understand for students that may not get it right away. This showed because my students got into the top universities in the nation. They've gotten 5s on their AP exams, perfect scores on their SATs, and eventually, are very successful right now. But most importantly, they had fun along the way. And that's what's most important, having fun while learning math. Unheard of, but today I'm here to show you what that's going to be like. Really excited what I have planned for you today on similar shapes. Again, this is geometry, a free lesson, and hope you enjoy and participate today. All right. So I love starting off my lessons off with something called an APK. An APK stands for accessing prior knowledge. And when we access prior knowledge, what we're basically doing is ensuring that we understand things that may show up later in the lesson without having to step aside mid-lesson to learn these things. So first off, two shapes are called similar if they are the same shape, just a different size. So this is also called dilation. We may have heard of dilation before in geometry class already, since you are probably about a month or maybe even a month and a half into your school year. You may have heard of this before already. Given that the following two triangles are similar, let's try to find the missing value of x. So we see this first shape, we have 3 centimeters for one of the sides and 5 centimeters for one of the sides. Also notice that the two angles that are congruent are in the same place for both of these triangles. These problems can get more challenging if these angles are switched up, and now you have to start making sure you're working with corresponding sides and corresponding angles. So now, does anyone remember in the chat how we would find this missing value of x right here? How would we look for this missing value of x. Does anyone remember from these two similar shapes? Anyone would like to enlighten us? Oops. How to find x here? We have two similar triangles. We know that 3 centimeters and 10.5 centimeters are somehow related. We know that the 5 centimeter side and the x is also somehow related. How can we combine all these relationships into maybe one equation that we can solve for x? And thankfully, our only variable here is x. So we're very thankful for that. And for those of you that may not remember, okay, great. On YouTube, I see a couple answers. We know that 3 centimeters and 10.5 centimeters are proportional. So we can say 3, oops, let me go to pen. And then let's choose red. Actually, yeah, red should be good. We can go 3 is proportional to 10.5 as 5 is proportional to x. Another thing to note here is that all the units of measure are the same. If one of them were in meters and the other were in centimeters, then we would have to do some unit measurement changes before we set up this proportion. Now, in order to solve for this x, there are multiple ways of doing this. Another way we could have set up this proportion is we could have set up this proportion as 3 is to 5 as 10.5 is to x. This is another way, and this is a reminder of how we can work with order of operations or any type of operations to move certain numbers around, especially when we're working with fractions, which I know most people struggle with, right? Fractions is so tough to teach, and that's why most people struggle with it, but you will not be struggling with it after my course, obviously. But let's solve for x here. We want to multiply both sides by x to bring x to the numerator. So we're going to multiply both sides by x. And while we do that, we will also multiply both sides by this 10.5 to bring that to the numerator. Or in other words, cancel it on the left side of the equality and multiply it times a 5 as well. So we multiply both sides by 10.5 as well. And here we have to be careful to make sure to distinguish decimal points with the multiplication. So 10.5s cancel out, the x's cancel out, and all we're left with on the left is, I was going to say, x times 3, which is 3x, equal to, we have 5 times 10.5, which is 52.5. We divide both sides by 3, and that'll give us 17.5. Now, I just did that really quickly mentally because that's not what we're focusing on. We're not focusing on the order of operations here. We are focusing on preparing these proportions, forming equations based off of certain shapes and relationships that we find in order to solve for some unknown. And that's the big thing about math, right? Especially in geometry, we're working with a lot of shapes that we may not be as comfortable with, or maybe some of us, geometry is more intriguing because of the shapes, but we're trying to create equations, mathematical explanations for relationships that we see in certain shapes. So that's our APK for today. Hopefully you understood that, and you'll need this for later on in future slides. All right, next, we have similarity. Given that the following two quadrilaterals are similar, find the missing values. Now, if we just dive straight in and just, create a proportion, we might get stuck. For example, all the sides are, well drawn, corresponding angles, great, congruent angles, awesome. These quadrilaterals are similar. We're given that information. However, if we were to set up an equation where 9 is proportional to x, so we can say 9 is to x as y is to 20. So y is to 20. Again, we make sure that all the units of measure are the same as well. I almost forgot to do that. Could have made a mistake if one of these centimeters were in meters. But now we have an equation with two variables, unsolvable, right? If we have an equation with two unknowns, we cannot find either of those variables. However, if we have two equations with 2 variables, we are able to do so. In this case, it's much easier to recognize that we have 10 is proportional to 16. So we can use that in order to isolate each variable separately. So we'll have 10 is to 16 as 9 is to x. 10 is to 16 as 9 is to x. Now, why did I use 9 and x first? Well, I used 9 and x first instead of y and 20 because I recognize that 20 is a bigger number. I recognize that 20 is a bigger number. I like to work with smaller numbers. This goes the same for when I work with either positive or negative numbers. When I make a decision, I decide to work with the positive numbers because whenever I work with bigger numbers or negative numbers, the probability that I make a careless mistake skyrockets, right? We want to lower the probability of careless mistakes, especially on exams and assessments where there are so many problems that things might get mixed up. Okay. Now let's solve for x here. Luckily, this time we won't have to multiply the left side by anything because we are able to just isolate the x almost right away. We have x times, and right here, 10 and 16 have a common factor, so we can cancel out a 2. And so we'll have x times 5/8 equal to 9, since the x is canceled on the right. In order to isolate the x, I can multiply both sides by something. In the chat, let me know, what can we multiply both sides by here to get to x? Yes, Anne, exactly. We can also eliminate variables this way, right? We can also eliminate variables, or in this case, we are canceling, right? If you're following me on any socials, or if you found this free lesson via my socials, you know that I have a video on the difference between cancel and eliminate. They are two completely different things. Cancel means we are making into 1, and eliminate means we are creating a 0, right? 2 things eliminated create a 0, whereas when we're canceling 2 things, we are creating a 1. What can we multiply both sides by here to isolate the x? Great. Multiply by its reciprocal. Great. I see we're using math terminology, and that's awesome. A reciprocal is when we multiply a term by something, its reciprocal, to get to 1, right? To get to 1. So we're going to multiply by the reciprocal of 5/8, which is 8/5. I see a lot of you joining now. Welcome. Maybe, there was a lot of traffic. You just got home. Awesome. Thank you for joining. Logan, I see you're back. Justin, welcome. So we have 8 and 8 cancel out. 5 and 5 cancel out as well. So now we have x is equal to, when we multiply numbers or fractions, we multiply straight across the top, straight across the bottom. So we have 9 times 8 is 72/5. If your teacher wants this in decimal form, 5 goes into 72. How many times? 14.4 times? 14.4 times. So either way works for me. If they wanted it in improper or proper fraction form, is that how you, is not proper fraction? Oh, mixed number form. It'd be 14 and 2/5. That's another way we can write it as well. Oops, I see that I'm covering the answer with my cam. So I'll write it right below so you can see what I wrote here. 72/5 is the same thing as 14.4. Which is the same thing as 14 and 2/5. Just other ways to write it. Great, and multiply by 8/5. That's correct. Awesome. So this is, again, similarity. We're slowly getting there. In the beginning of my lessons, I like to have as many re-entry points as possible, so we're all in the same place as we move forward. As we move forward in the slides, the problems will get increasingly more challenging. So for those of you that think, oh, this is way too easy, what am I doing here? Just wait and see. It will get a little more challenging. We're just trying to activate activate our brains here so that we can access the later, more challenging problems. All right. Let's take a look at this one. Find the length of line segment CD. Now, this is the first time today we are seeing a shape that looks like just one shape. However, If we were to split these shapes up, we know that they're still similar. Why? Because they share the same angle, first of all. They share the same angle, and these two lines are parallel. So if we were to redraw these two triangles, I would have the smaller one, and the smaller triangle I would call A, C, D, and the bigger triangle, if I were to try so hard to make this as accurate as possible, tried my best there. We have A, O, and B. Okay, now what do we know? Let's label as much as we know. We know that this is 6. We know that this is 17.5. What is this going to be? AO. What is AO? And I'd say the most common mistake students make here is not redrawing the triangle and going straight into just creating a proportion. The biggest mistake students will make is they'll write 6 over 8 is equal to this line segment CD over, oops, let me elongate that, over 7.5, like that. And this would be incorrect. And why would this be incorrect? What would the length of segment AO be? In the chat. If we can find the length of segment AO, we can create a proper proportion to solve for the length of line segment CD. And I'm going to put an X here because that's what we're looking for. Great, Anne. 14 is correct. And how did you get 14? Just for those of us that may be struggling to find what line segment AO stands for, or the length of AO is. How did you get 14? Anne says line segment AO is 14. Great, Jimmy. I see you got it as well with a question mark. And you are correct, right? Also, don't be afraid to make mistakes. The brain research strongly suggests that whenever you make a mistake and you fix that mistake, that's when true learning occurs. If you're always doing the correct thing, you're not learning anything. You're just kind of wasting time. That's how I think about it. So if you're solving challenging problems and you make a mistake on the way and you fix that mistake, that's when true learning and true retention occurs. That's why rote memorization does not work. Because if you're just memorizing how to do certain types of problems, you're not really learning. You're just copying, right? And copying is not learning. 6 plus 8. Great, Anne. Great, Jimmy. Love that explanation. We have 6 plus 8 to get the entire length of AO. Awesome. So we have to add the 8 centimeters and the 6 centimeters. And now we are able to create a proper proportion equation. We can set up 6 is to X, or this time, let's try something different. This whole time, we've been putting the variable in the denominator. But would you agree that if we put the variable in the numerator, our work would become a lot more simple? Like if we put X is to 6 as 17.5 is to 14. Right? Or in other words, we can also put X is to 17.5 as 6 is to 14. Another way to do it. But which way would be better to solve? Which one would be more convenient to solve in your opinion? 1 or 2? Which is nicer? Which looks nicer? And it just so happens I wrote down these two equations in this order. It was completely random. But which way would you prefer to solve for X? Number 1, option 1, or option 2? Both have an X in the numerator. So this time, all we'll have to do for both of them is multiply by the denominator of X each time. But which one would be simpler? Which one looks better? Is it easier to multiply both? Exactly, right? It's easier to multiply both sides by a 6 than it is to multiply both sides by the 17.5. Actually, in reality, they're both going to be the same thing. Yeah, it's the same, Logan. Great, right? Jimmy says, Yes, it's technically the same thing because 17.5 times 6 is the same thing as 6 times 17.5. But just by looking at it, which one looks less daunting might have been a better question. It would be multiplying both sides by 6, right? Because multiplying both sides by a decimal might be a little more challenging than multiplying by a smaller whole number like 6. So x is equal to, now 6 and 14 have a common denominator of 2, and I always try to cancel out common factors before I multiply. Because if I do 17.5 times 6, that's going to become a much larger number than if I did 17.5 times 3. 17.5 times 3 is 52.5, and I'll be dividing, 52.5 divided by 7. And here's something cool. If we're comfortable with our multiplication tables, we can rewrite this as a decimal as well. 7 times what number gets us really close to 52.5? 52.5. We know 7 times 7 is 49. Since we know 7 times 7 is equal to 49, how much left is between 49 to get to 52.5? That would be 3.5 over 7. And what is 3.5 over 7? That's just 0.5. So our answer here is 7.5. X, line segment CD, has length 7.5. And whenever you are given units, I think I forgot to do this in our previous problems as well, so we'll go back to do it. This is a very common error. I'm glad no one caught it, or shame on you for not getting me. It'd be 7.5 centimeters. Don't forget your units of measure. Whenever you are given units of measure, you must include units of measure in your final answer. So previously, we should have put centimeters here as well. And I think our previous problem before that as well, we should put centimeters as well. All right. Well, glad we caught that before we went any further, or else we would have had to go back multiple slides later on. All right. Given what we just did, I want you to try to find an equation for this. So I'll be talking a little bit here. I'll give you a head start. Again, the workbook is the first link in the YouTube description. So you can access that workbook so you don't have to be drawing all this. That's one of the pain points of learning math in school, is that you're not provided graphic organizers, or you're not provided workbooks, and you have to copy all this stuff down. And that's such a waste of time, right? In my lessons, you'll be just focused on the learning. Be focused on the learning. You don't have to worry about copying things down off the screen. You can just annotate straight onto your workbook. All right, so I did give you a little bit of time here to try to find an equation, form an equation. We just talked about forming equations in my free lesson on Algebra 1 last Thursday, if you want to check out my YouTube for that one. But we forming equations here, we know to redraw these triangles. Always redraw when you can. Get used to redrawing things, right? Get used to redrawing things as best as you can. As best as you can. Talking to myself there. ACD and AOB. All right. We know that the length of AC is X. That's the value that we are searching for. CD is 10, and I'm going to write centimeters here this time just so I remind myself at the very end, X has to equal some value in centimeters. Whenever you're given units of measure in the problem, your answer must also have that same units of measure. AO. I know Anne and Jimmy can help me out here. Yes, you can print the workbooks as well. You have X plus 12. AB, we don't know, and we don't need because we don't have AD either. We're looking for OB, which is 15 centimeters. And now we can set up an equation. Welcome back, Chloe. All right, Anne says 10 over 15 is equal to X over 12. Let's check it out. So we have X is over to 10, is proportional to 10 as X plus 12 is proportional to 15. So, Anne, I'm really glad you made that mistake, because now you can fix it and it'll stick, right? This is a lesson. Nothing is graded. Take a chance, right? Make that mistake right now, so that after the lesson, when you get your practice problems, when you register for my course, When you get those practice problems, you've already made those mistakes during the lesson. So when you do those practice problems, you can treat it like a quiz, an assessment, an exam. And then after that, you'll also get video solutions on top of that to make sure your work is correct. So multiple times for you to master the work. Whereas if you don't participate in class and don't make those mistakes, now you're going to be making those mistakes on your practice problems, and you only get one chance instead of two chances, right? Each chance is so critical. So now we have x is to 10 as x plus 12 is equal or is to 15. Not equal to, but is to 15. Great. I see all of us know each other in the chat now. Love it. Love all of you that are returning today. Let's solve for x here. I'm going to multiply both sides by the denominators of each fraction. So I'm going to multiply both sides by a 10. And that will cancel out these 10s. And I'll multiply both sides by a 15 as well to cancel out the 15 in the denominator on the right side of the equality. All I'm left with then is 15 times x. And be careful here. Be careful here. 10 must be distributed to both terms in the parentheses. 10 must be distributed to both the 12 and the x. So 10 times x is 10x, and 10 times 12 is 120. And now we combine like terms. Let's see who can get x the fastest in the chat here from this point forward. 15x is equal to 10x plus 120. We're going to combine like terms. And I always like to keep the coefficients of my variables positive. What I mean by that is I'm going to keep the larger coefficient of x on the same side that it already is. I'm going to leave it on the same side. In this case, 15 is a larger coefficient of x than 10 is. So I'm going to leave this 15x on the left side of the equality and move the 10x over. Or actually, let me put the arrow under so it's more aesthetic. We'll put minus 10x. Whenever a term is being added or subtracted on either side of the equality, if we move it to the other side of the equality, we are flipping the sign. And an easy way to remember that is whenever something is equal to something, eventually what that means is that 0 is equal to 0. This equality is like on a number line, a 0. So if you have a positive number on this side, you flip it to the other side of 0, it becomes negative. Same idea. If you have a negative number on one side, you move it to the other side, it becomes positive, right? So treat the equal sign like a 0, and it'll never fail. So now 5x is equal to 120. I see some answers in the chat. X is equal to 24. Awesome. But be careful. A lot of you put x is equal to 24, but that would be marked as not fully correct. Why? What are we missing? Great. I love that you put it step by step as well. 5x is equal to 120. X is equal to 24. But what are we missing here? Wow, cold hard cases. I just wanted to say thank you for helping me pass my first test in grade 9 this year. Awesome. I'm glad my lessons are helping. X is equal to 24. But what's missing? We made this mistake in the previous 3 slides. And because I made that mistake and I fixed it, I'm not going to forget it again here. The units of measure is in centimeters for this entire problem. So my answer must also be in centimeters. If I just put 24, that 24 is ambiguous, right? As the grader, I'm thinking 24 what? You could have meant inches, yards. Doesn't matter. It's not obvious, right? That it's in centimeters just because the shape says so, right? You have to be precise. Yes, cm, 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 cm. All right, great. Moving right along. We're going at a really good pace here. Let's check out area and volume. Now, this is where it gets really exciting because we're no longer just worrying about the lengths, right? One-dimensional lengths. Now we're going to start entering two-dimensional and three-dimensional territory. And this is where similarity gets really, really interesting and exciting. Let's take a look. Let's look at what happens when we enlarge shapes and calculate the new areas and volumes. Find the area of both triangles, given that they have been dilated by a scale factor of 5. Now, a scale factor. A scale. What's a scale? A scale is kind of like a range, right? It's a range. Or you can think about the scale that weighs things, and they have to be equal. So a scale factor of 5 means each length has been multiplied by 5. So 1 centimeter has become 5 centimeters, and 4 centimeters has become 20 centimeters. Now let's find the area of both triangles. What's the area of a triangle? Really quick in the chat. What's the area of a triangle? The area of a triangle is equal to, we know that the area of a box is base times height. So the area of a box is base times height. And a triangle is half of that box. Great. So those of you that put 1/2 times BH or B times H over 2, both are correct. But if you have true understanding of where this area of a triangle comes from, I would write it as 1/2 B times H, 1/2 of base times height, because we have half of the area of a box, and that's where the area of a triangle comes from. Or length times width times 1/2. Welcome back, Jiyoung. Yes, great. Base times height can also be called width times length, because usually the base will be the width of something and the height will be the length of something. Great. I love that you mentioned that in the chat. Thank you for that. So let's find the area of this first rectangle. 1 times 4 is 4, divided by 2 is 2. 5 times 20 is 100, and take half of that to get 50. So now what did we multiply 2 by to get to 50? What did we multiply 2 by to get to 50? And let's see if that has anything to do with the scale factor of 5. And this is where math gets so cool. So I'm so excited to show you this. I hope you get it before I have to tell you, because if you can get it before I tell you, that's when you know, right? That's when you know I've set this problem up correctly for you. So 2 to 50. What did we multiply by? 2 to 50. We multiply by 25. Great. And how is 25 related to a scale factor of 5? And while you figure that out, let me prove to you why 25 makes sense here. And we didn't have to solve the areas in order to find the differences in areas, right? The relationship between the areas of these triangles. And let me show you. The area of this first triangle would have been base times height divided by 2. Now, with a scale factor of 5, what does that mean? That means each side is being multiplied by 5, correct? 1 became 5, and 4 became 20. So if we go, okay, 1 times 5, and then 4 times 5, all over 2, this should be the area of our second triangle. We'll take a look. If we, multiplication is commutative, so we can rearrange 1, 5, 4, 5 however we'd like. This would equal 1 times 4 over 2 times 5 times 5. And what is 5 times 5? 25. And why does this work? This works because area is two-dimensional. Area is two-dimensional. So if a length, a one-dimensional length, has a scale factor of 5 from one figure to the next, a two-dimensional figure should have that scale factor squared. 5 squared, right? So now let's take it to 3 dimensions. Let's take it to the next dimension. Find the volume of both cubes, given that they have been dilated by a scale factor of 3. So let me ask you this, right? Let me ask you this. We know that 1 times 1 times 1, the volume of a cube is going to be whatever the length is cubed. So it's going to be 1 centimeter cubed. Now, without solving the volume of the second shape, the second three-dimensional cube, we know that this cube has been dilated by a scale factor of 3. So can you guess what the volume of the cube will be based off of just the scale factor of 3. We worked with 2 dimensions already with area. We said square the scale factor because we are now in 2 dimensions looking for areas. Area is 2-dimensional. But now we're working with 3 dimensions. So volume, if we have a scale factor of 3, we're no longer squaring the scale factor, but now we are exactly 3 cubed, 20, correct, amazing. Volume is equal to 3 cubed, which is 27 centimeters cubed. Amazing. Now, again, this is just for you to grasp right now. We're going to try some more challenging problems here. So stay tuned, okay? There's a really challenging problem coming up that I can guarantee that if you did not see this before, your mind is going to be even more blown than it was right now. Yeah, right, Anne? Wow. 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 This is the cool stuff. This is why I believe geometry is pure mathematics. Geometry is pure mathematics. If you are able to understand and explain mathematics using images, using visuals, that's when you know you truly understand these mathematical concepts. And that's why I believe if you love geometry, you didn't like algebra, and you love geometry, then you love math. If you like algebra, you like arithmetic, not math. So let's learn to love geometry, learn to love math. All right, let's take a look at these. These are examples from our previous one. So let's see if you can get it in the chat here. Shape A is dilated by a scale factor of 4. Okay, what does that mean again? Dilated means the shape is being, it's growing or it's shrinking, but the shape itself is similar, right? It's staying the same dimensions. So shape A is dilated by a scale factor of 4 to produce a shape B. The area of shape A is 5 centimeters squared. So this time we're not given what the shape is. So it's impossible for us to find the area separately. We're only given the relationships between the two shapes. So shape A has area. Oh, let me write it like this. Let me write it area of shape A. This will be interesting. Area of shape A is 5 centimeters squared. So the area of shape B, what is that going to be? We know that the scale factor is 4. What could we multiply the area of shape A by to get to the area of shape B without having to think about what this shape looks like, any other information? We are given all the information that we need to know here. We know that the area of shape A is 5 centimeters squared. Scale factor is 4. So a scale factor means each length on shape A multiplied by 4 will give the corresponding length of that side of shape B. So we're not multiplying 5 by just a 4. This is a 2-dimension, area is 2-dimensional. Exactly. So we're multiplying by 16, which is 4 squared, right? The area dilates by a scale factor of k squared if the scale factor is k. K is equal to 4. We're going to multiply by 4 squared, which is the same thing as multiplying by a 16. 5 times 16 is 80 centimeters squared. Beautiful. Isn't this so cool? Now let's check out the second example. Shape A is dilated to produce a shape B. The area of shape A is 10 centimeters squared. Okay, the area of shape A is equal to 10 centimeters squared. And the area of shape B is 250 centimeters squared. If shape B has length 2.5, okay, so shape B, what should we call it, that length? Let's call it, I don't even know what to name it. Some length is equal to 2.5 centimeters. Then what length does shape A have? Okay. So math is all about the study of patterns. Patterns are all about relationships. So let's think about, so essentially mathematics is the study of relationships. 10 to 250. What did we do to 10 to get to 250. Again, we're not adding, we're not subtracting, we're not dividing, we are multiplying, right? We are multiplying. 10 to 25, we have multiplied by 25. This time, we're not given what the scale factor is, but given this information, what is our scale factor? Given this information, what is our scale factor here? We know that the areas have increased by a factor of 25. What would be the scale factor for just the lengths of between these shapes? Yes, Logan, we are multiplying, correct. Times 25, great, Jiyoung. Times 25, and that can be rewritten since we know 25 is going to equal k squared. K is equal to the square root of both sides here and the square root of 25, or in other words, a number squared that gives us 25. Great, IMS, mom on Instagram. Awesome. K is equal to 5. Awesome. So we multiplied by 25, a scale factor of 25 to get from one area, from area of shape A to the area of shape B. We're given the length of one of the sides of shape B, and we want to go back to the length of shape A. So is the length of shape A going to be smaller or bigger than the length of shape B? Is the length of shape A going to be bigger or smaller than the length of shape B? Right, think about that for a second. Right, we're trying to make sense of this problem so that when we find the answer, it truly makes sense. Right? What is that phrase? Make it make sense. We're trying to make it make sense. Exactly. Length of shape A is going to be smaller, right? We just multiplied the area of shape A by 25 to get to the area of shape B. So if we're going backwards, what operation will we be using? Multiplication, addition, subtraction, division, square roots, factorials? What are we going to be using here to get from 2.5 to the length of shape A? What would we use? If the length of shape B is 2.5 centimeters, we know that the scale factor for the areas was 25, increasing. So going backwards, great, Jiyoung, we'd be dividing, right? Dividing specifically by what? And I'm going to rewrite while you guys type out that answer. I'm going to write this as 5 squared. Great, Logan. Division by the scale factor of 5. Beautiful. 2.5 divided by 5 is 0.5. Don't forget our units of measure, centimeters. Now, let me show you something really cool. The area of shape A to the area of shape B, we multiply by 5 squared. And notice the units of measure. The units of measure for area were also squared. So it makes sense that our scale factor is also squared. Now, for the lengths of shape A and shape B, I could see how the A's can get kind of confusing here, but hopefully you got that. I'll try to be more careful with that with future problems. We have centimeters, and that's one-dimensional. So we want to divide by a one-dimensional scale factor as well. If we were dilating by a scale factor of 5 squared, working with area, dilating lengths, the scale factor should be just to the first power, right? To the first power. One-dimensional. Okay. It's going to get more challenging from here, so lock in. This is one of the toughest questions we'll be solving today. The 3D shapes below are mathematically similar. Okay, so we're given these shapes are similar. There will be a scale factor, and we're going to be using at least volume because in the images we see V, right? V stands for volume. Not only that, the units of measure are cubed. That's how we know this is talking about volume of each of the cubes. If the surface area of shape B, let's call this B, and let's call this A. If the surface area of shape B is 22.5 meters squared, What is the surface area of shape A? Oof. Okay, let's take a look. The surface area of shape B is equal to 22.5 meters squared. So in some way, we have to use a scale factor to get to the surface area of shape A. This is what we are looking for. But we're given volume. Okay, let's take a look. Let's write the volumes down as well. Because right now we have absolutely zero information just from this. We have zero information on what we can do. So we're going to use some more information that we were given. The volumes are going from 5 meters cubed to 135 meters cubed. So how did we get from 5 to 135? Let me do that quick maths for you. 5 to 135 is 5 times 27. So we're multiplying by 27. What's another way to write 27 since we know we're working with volumes? 27 is a cubic number, right? 27 can be written as some number cubed, and that number is 3. 3 cubed is the same as 27. So how does that help us with solving for the surface area of shape A? Great, Chiang. I see you got 27. Awesome. How does that help us with this relationship right here? What goes right here? We know that it's going to be division. Okay, I'll give you that hint because we did that in the previous problem as well, right? We divided by 5 to get back to the length of the shape A. This time, we're also going to be dividing because we're going backwards once again, right? We're going from a bigger shape to a smaller shape. So this time, what are we going to be dividing by? Bonus points for those of you who can get this one. And don't be afraid to make mistakes. This is a difficult problem. Okay, this is a challenging problem, but give it a shot. What do you think it will be? Make the mistake here. You're going to get a problem like this just on your practice. Make the mistake here, fix it so that when you take that practice problem, you're going to be like, oh, I've seen this before. Like I remember the mistake that I made. This time, let's try it the way that I remember it, the way that I fixed it. What would we be dividing here? Or what would we be dividing by here? We multiply it by 27. We know we're working with 3 dimensions, so that's why we rewrote 27 as 3 cubed. Now we are working with surface areas. Surface areas. Area is 2-dimensional. We're no longer working in 3 dimensions. We are working in 2 dimensions. So what can we divide by? Have we found K? Let me ask that first. Have we found scale factor K? The volume was dilated by a scale factor of K cubed. So if K cubed is what we multiplied by, K is then equal to 3. Okay, I see some guesses coming in. I love that. Love the question marks because now we're thinking, right? That's what's most important here. Learning is active. You have to participate, even if it's not in the chat and you're just participating yourself in your head or on your paper. That's great as well. But you have to actively think, right? That's active learning. That's actual learning. If you're just copying things down in school, you're not really learning, which is probably why you're not doing well on your tests as well. So K is equal to 3. We're working with areas here. So we're going to divide by K squared, which is 9, like Chiyoung said in the chat. Amazing. So now we have 22.5 divided by 9. 22.5 divided by 9. Let's think about this as well. How many times is 9 going to 22.5 fully? Twice. Because 9 times 2 is 18. How much more is 22.5 than 18? 18 to 22.5 is 4.5. Well, we're dividing by 9. How convenient. 4.5 is half of 9. So our answer is 2.5 meters squared. And that is the surface area of shape A. And we didn't even have to know the dimensions of either of these shapes. All we knew were the volumes of these two shapes. We knew that these two 3-dimensional shapes were similar. And we knew the surface area of just one of them. And that was enough to find the surface area of the other one. relationships, right? The study of patterns, the study of relationships. That's mathematics and perfectly shown in geometry. I love geometry. All right, next question. Let's try this one. In the diagram below, this is an SAT question, straight off the SAT. And in my geometry course, I'll always be putting at least one SAT problem, either per lesson or per week, because I know that once you get to geometry, which is usually taken in 10th grade, if you're taking it way earlier, that's awesome. If you're taking it later, that's all good. You'll be reinforcing your skills. But in 10th grade is usually when students start to prepare for the SAT. And that's why I put these SAT problems at the end of my lessons in geometry and in Algebra 2. Let's check this one out. In the diagram below, EB is parallel to DC. Boom. AE is equal to 9, ED is equal to 5, AB is equal to 9 should say 9.2 here. Let's change this to a 2. 9.2. What is the length of AC to the nearest tenth? So we're looking for this, and let's call that X. First, let's redraw these triangles, because right now, especially on the SAT, when you have less than a minute and a half to solve each problem, we need to take care of our time, right? We have to consider that, and there's so many problems we're solving rapidly, we don't want to make any careless errors. So it's best to be safe than sorry. So we're going to redraw these triangles as best as we can. And so this is A, E, B, right? This is a throwback to the beginning of our lesson. Can you believe it's already been an hour? Time passes so fast when you're having fun. A, D. 9 plus 5 is 14, and this all is X. So let's create that proportion. X is to 9.2 as 14 is to 9. And now we solve for X by multiplying both sides by 9.2. 14 times 9.2. Ooh, that's a tough one. Does anyone know how to do that off the top of their head? I think that's 126 plus 2.8. So 128.2. 128.8. Somebody check me on that, please. All over 9. And that's what X will be equal to because the 9.2s cancel out. So we have 128.8 divided by 9. This is actually really doable. This is, I believe, are they divisible actually? 1, 4. These are not divisible. Is it divisible by 3? Not divisible. So this is what we would leave it as. X is equal to 128.8 over 9. Are we given units of measure? No, we are not. They want the length in nearest tenth. I almost got the question wrong. Nearest tenth. So if we go 128.8 divided by 9, what we can do on the SAT, you have a calculator. I'm going to keep all my work because I don't want it to disappear. And I'll go to calculator. We'll go 128.8 divided by 9. So I have 128.8 divided by 9. And that gives us 14.3. 14.3. Is this what I want? Oh, oops. Great. We get to go through all the slides again. 14.3. X is equal to, or let's put squigglies, 14.3. All righty. Let us solve our last problem for today. And I'm going to model this one. Great, Anne. I see you got it. Logan, I see you're getting it as well. Chiyoung as well. Awesome work. Let's do this last one together. A street lamp casts a shadow. Let's draw the street lamp. Here's the street lamp. Boop. With a street lamp. Casts a shadow. All right, it casts a shadow. There's the shadow. So we have this little right triangle. Here's the shadow, or sorry, this is, the shadow would be here, right? This is the shadow. And this length is 16.4 meters. Michelle stands 12.55 meters from the base of the street lamp. So here's Michelle. And she is standing. Let's do this in a different color. Also, next time I would use the line function for this to make straighter lines. But for now, this will have to do. In green, Michelle is standing 12.55 meters away from the street lamp, from the base of the street lamp, such that the end of Michelle's shadow meets the end of the street lamp's shadow. Great. So they're both going to meet right here, which is awesome. If Michelle is 1.52 meters tall, all right, that's good to know. Michelle is 1.52 meters tall. Determine this, the state and determine and state the height of the street lamp to the nearest tenth of a meter. So this is what we're looking for. We are looking for X right here. So we'll have, let's set up our normal proportion. But in this case, we have to do a little extra work. We have the bigger triangle and our smaller triangle. Our smaller triangle, the height is 1.52 meters, but this is unknown, but we can find it. We could do 16.4 minus 12.55. So that'll be 3.95. I'll be doing all the mental math more quickly here just to model for you. Here's X and here's 16.4 meters. Okay, we're ready. Oh, I believe it's 3.85. Sorry about that. 3.85. If you see any of my math incorrect, let me know in the chat, but I believe this is correct. And now we'll have X over 16.4 is equal to 1.52 over 3.85. And now we can solve for X. 16.4, 16.4, and we'll plug this into a calculator. And that would be our answer. For the sake of time today, we're not going to solve all the way through, but forming these equations is the toughest part about these problems. The order of operations and isolating X is not as tough, especially when we're first talking about similar shapes here. But hopefully these types of problems were challenging enough for you to be able to decide whether you've mastered this concept or not. Now, if you're still here and you enjoyed the lesson, call your parents over or put a W in the chat for this W stream. And let me share with you something really special. Here we go. Our lesson may be ending, but your progress doesn't have to. My Edspace, Geometry, the full year course starts on October 6th. Each course includes 2 engaging live and interactive lessons each week. So just like this, twice a week. Every lesson is video recorded or is recorded, so you can revisit it and review it at any time. Especially if you have some family event or extracurricular activity and you can't make that lesson, it'll be recorded for you to review later in a later time. Professionally designed workbooks like the one that you see in the link below in the YouTube description. Practice with exam-style questions after each lesson to ensure that you've mastered the material before you attend the following lesson. And I don't leave you hanging. Another opportunity to learn. I make detailed video solutions on all the practice problems you'll ever get after each lesson. And you'll have access to them after you do the practice problems. But how much is it? For context, when I used to be a private tutor, how much do you think I used to charge per hour? And I know Jiyoung and Logan, all of you that were here before, you already know how much it is. So don't spoil it for the others. But for those of us that are new here, how much do you think I used to charge as a tutor way back when? Per hour. In the very beginning, when I used to tutor and volunteer in high school, I used to do it pro bono. So completely free. It's for the public good. That's what pro bono means. And then in college, I used to charge about $30 to $40 an hour, depending on what that subject was. But, as a college student, I only know so much. I can do homework help. I can, look at the exams that students have taken and help them figure out what they did wrong. But I can't ever foresee or foreshadow what the teacher might be going to be covering in the future. And now with 9 years of experience teaching high schools, colleges, private tutoring, all grade levels from 6th grade math all the way to students preparing for graduate school. Yeah, for those of you who are returning, you already know how much I used to charge as a private tutor. A minimum of $100 per hour to up to $200 per hour for students preparing for more impact exams like the GRE and GED, or not GED, GRE, the MCAT, and things like that. And that's the problem. Families always have to choose between what works and what they can afford. Effectiveness versus affordability, you can never get both. And that's why we created My Headspace. All of this for just $99 a month, which is 8 times cheaper than what I would have been charging, um, 8 times 8 hours per month. And why stop there? If you are able to, if you're interested in buying the full course, we have a 20% additional discount on our annual package. And to protect you from any risks, we provide a 30-day risk-free full refund guarantee. And it's a first come, first serve basis. So it's a limited time offer. If you're interested, text me code word START to my number, 512-900-1283. If you want to take a screenshot of this because your parents are not around right now, feel free to do so as well. This lesson is also being recorded. So you can always come back to my YouTube channel, Eddiedoesmath. I'm also across all socials, Facebook, Instagram, TikTok, YouTube. I already mentioned YouTube. A new Instagram post and TikTok post just went up today as well, so you can check those out. On TikTok, I'm posting daily SAT math questions. So if you're studying for the SAT, know that you'll be getting that in my geometry lessons at the end, right? These challenging problems you will be seeing on the SAT. I'm implementing them into my lessons as well. Things that you probably won't be seeing in school. So if you're interested, text me that code word START to this number. And I'm excited to continue your journey with me at My Headspace. Again, the course starts very soon. It starts on October 6th. It's 2 weeks from today. So if you're interested, text me. We can talk more about what you need, what you're looking for, and see what's best fit for you. In the meantime, follow me on socials if you want to continue to interact with me. Thank you for tonight's evening. Jiyoung, I teach pre-algebra, algebra 1, geometry, and algebra 2. So whichever course you need, feel free to reach out. If you're looking out for a friend, a family member, maybe a sibling, your parents don't know about this yet, let them know about it. Great. Awesome. I look forward to hearing from you or all of you that joined today. Thank you for your time. Have a beautiful evening, and I will speak to you soon. See you tomorrow for Algebra 2. Bye, everybody. W's